Oscillations. ABCD, the diameters of a circle with the center O. A particle starting from A and covers through the circumference of the circle with the uniform angular velocity omega. Omega is angle covered by time. Angular velocity is angle covered by time. So theta omega t. Let this particle covers an angle theta in t seconds. So the angle covered is theta in a time t second. So angular velocity is angle covered by time. Usually linear velocity, displacement by time. Instead of displacement, here it is angle. Angle covered by time. So theta is equal to omega t. So when here the particle travels through the circumference of the circle with the uniform angular velocity omega. Angular velocity is expressed by the term omega. And when the particle takes one revolution, the angle covered is 2 pi, that is 360 degree. Time is t, that is angle covered is theta 360 degrees, so omega is equal to 2 pi by t. So t is equal to 2 pi by omega. Angular velocity is angle covered by time. Angle covered is 360 degree, that is 2 pi by t. T is equal to 2 pi by omega. Here, this is taking this revolution. Q is the foot of the perpendicular from the particle to the diameter. So here, when the particle covers from A to C, particle is at A, Q will be at here. Particle here, Q will be 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 here. Like that, when P moves from A to C, Q moves from O to C. Particle covers from A to C, Q moves from O to C. P A to C, Q O to C. When the particle moves from C to B, like this, what will be the motion of Q? Q moves from C to O. P moves from C to B, Q moves from C to O. And particle moves from A to C, Q moves from O to C. When particle moves from C to B, Q moves from C to O. When particle moves from B to D, P moves from B to D, like this. Q moves O to D. Particle is at here, Q is at here. Particle is at here, Q is at here. Particle is at here, Q is at here. Particle is here, Q is at here, like this. When P moves from D to A, Q moves from D to O. P moves from D to A. When P is at here, Q is here. 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 P is at here, Q is here, like that. When P moves from D to A, Q moves from D to O. So motion of Q. When this particle moves from A to C, the foot of the perpendicular from the particle moves from O to C, that is Q. When particle moves from C to B, Q moves from C to O. When particle moves from B to D, Q moves from D to O. Sorry, Q moves from O to D. When particle moves from D to A, Q moves from D to O. Once more I repeat. When particle moves from A to C, the foot of the perpendicular from the particle moves from O to C. When P moves from C to B, Q moves from C to O. When particle moves from B to D, Q moves from O to D. When particle moves from D to A, Q moves from D to O. This motion of Q about this diameter, this O is called mean position, or it is also known as equilibrium position. Mean position or equilibrium position. C and D, these two positions are called extreme positions. C and D are extreme positions. Q is the mean position. This O is the mean position, or it is called equilibrium position. The particle maximum goes up to C in this direction, if it is in this D. So C and D are called extreme positions. Here, when this particle makes one revolution, this Q moves from O to C, C to O, O to D, D to O. It takes one nose. One reva equals one nose. One nose means one oscillation. One to and fro motion. Comes here and it comes here and comes. From mean position, this motion comes here. This motion and comes here. To and fro motion. That is called one oscillation. So one oscillation is one to and fro motion. During one oscillation, there is one revolution. So we say one nose is one reva, or one reva is one nose. There is oscillation. This to and fro motion. So this motion of Q is here, here, then here, then here. That's called SHM. That motion is simple harmonic motion. It is a harmonic motion which is simple. Harmonic motion means repeating at regular intervals of time. That is simple. Harmonium. Sa, ri, ga, ma, pa. That is harmonium. Sa, that time, ri, that time, ga, that time, ma. That is music. That instrument is harmonium. There is only one. Then there is music scale instruments, so many. Complex harmonic motion. Here it is simple harmonic motion. Simple harmonic motion which is very simple. That is repeating at regular intervals of time. When you say if A to C takes 5 seconds, C to B also 5 seconds, B to D also 5 seconds, D to A also 5 seconds. For this, A to C 5 seconds, then O to C 5 seconds, C to B 5 seconds, C to O 5 seconds, B to D 5 seconds, O to D 5 seconds, D to A 5 seconds, D to O 5 seconds. That is repeating at regular intervals of time. That is called periodic motion. So SHM is periodic, that is repeating at regular intervals of time. That is oscillatory also. This motion is oscillatory motion, and this is a periodic motion that is repeating at regular intervals of time. And this SHM is defined as the projection of a uniform circular motion about any diameter of a circle. We are taking the diameter CD of the circle. This AC, that is the projection of motion OC. OC projection is AC. CO projection is CB. OD projection is BD. DA projection is DO. So simple harmonic motion may be defined as the projection of a uniform circular motion about any diameter of a circle. This diameter code can also be taken as this, like this. This also, the O to A to O, O to B, B to O. That is also an oscillatory motion, and this motion, this projection, this motion, this projection, this motion, this projection, this motion, this projection. So simple harmonic motion may be defined as the projection of a uniform circular motion about any diameter of a circle. It is oscillatory motion, it is harmonic motion, that is repeating at regular intervals of time. One oscillation is one to and fro motion, that is like this side, come here, then here, here. This O is mean position. And this is a maximum displacement. This maximum displacement from the mean position, here OC, that is OD. If you are taking this diameter, OA, OB. And that is the radius of the circular path. And it is called amplitude. Amplitude is the maximum displacement from the mean position. That is amplitude. It is the radius of the circular path. During one oscillation, you see there is one revolution, one nose. There is one revolution. During one nose, there is one revolution. So the angle covered is 360 degree. That is 360 degree means 2 pi radian. 360 degree is 2 pi radian. The angle covered during one oscillation is 2 pi radian. This is a phase of 2 pi. 2 pi phase we see. 2 pi phase angle. The angle covered for one oscillation, that is 360 degree or 2 pi radian, that is 2 pi phase angle. And during one oscillation or one revolution, the length of the path of the particle is, that is diameter of circular path, that is twice of radius. Twice radius. Twice amplitude. During one nose or one rava, the total distance travelled is length of this circular path. Total distance travelled is, that is here, 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 that is twice diameter is equal to 4 times radius is equal to 4 times amplitude. So that's the length of the path of the particle. The period you say is the time taken for one revolution or one oscillation. The frequency of oscillation, that is the number of O's per second. Frequency 2 Hertz means 2 per second, in 1 second 2 oscillation. So frequency is the number of oscillation. Angular frequency here is the number of oscillation per second. T is equal to 1 by n. So n is equal to 1 by t. Here you can write 1 by n is equal to 2 pi by omega. Therefore omega is 2 pi n. Omega is also 2 pi. So that is the basic points you remember. SHM, the characteristics of SHM. SHM is periodic, it is oscillatory motion, it is simple harmonic motion, that is repeating at regular intervals of time. SHM is the projection of a uniform circular motion about any diameter of a circle. Period of SHM is the time taken for one revolution or one oscillation. And frequency of oscillation is the number of O's per second. Omega 2 pi by t, t 2 pi omega, t 1 by n, n 1 by t. So 1 by n 2 pi omega, omega 2 pi n. Amplitude is the maximum displacement from the mean position. It is the radius of the circular path. And during one oscillation there is one revolution, one oscillation is one to and fro motion. During one oscillation the angle covered is 360 degree, that is 2 pi phase. That is phase angle is 2 pi. That is 360 degree, that is called this phase, 2 pi phase. And during one oscillation or one revolution, the length of the path of the particle is 1 diameter, that is twice radius, that is twice amplitude. During one oscillation or one revolution, the total distance travelled is the twice diameter of circular path, that is 4 times amplitude or 4 times radius.